Tui here. We're doing some more graphic stuff. Today, I think what we're probably going to do is some user input, some lighting maybe, and just a little bit of a refactor. And we're going to start with the refactor because this is something that we probably should do before we go any farther. Basically what we have in here is in this render class is we have just kind of too much code. We can separate this off into something what's called the renderable, so that this node right here knows exactly what a renderable is, and it can call renderable on all of its. If it's a child, it can call renderable. So let me start by creating a class called renderable. It's easy enough. Got a gig. My buddy's in a gig, so I gotta do this quickly. Shout out to Sam S. Let's see here. We're gonna call this renderable. That's just gonna be put there, and then this is going to be a protocol. And I'm gonna go like so. Renderable. Okay. So let's go into our primitive. Let's take some stuff out. Our primitive is a renderable, basically. So yeah, let's make it a renderable. That way, like in the future, we can have a texturable, a lightable. I don't know if that's a thing. Haven't done that yet. So what we're gonna do is we're gonna keep this primitive right here. We're gonna do render right here, and then we're gonna go over here, and we're gonna click on this button right here. And if you're blind, you have no idea what I'm doing. Yeah, so here's our renderable class. So it's going to be a protocol because we want things to have to write their own. This renderable will have a draw function, and what that'll mean is if we extend the renderable, then it will have to implement its own draw. Like if it's renderable, it'll have to have a draw, and so that's why we want it to be a protocol. I'll explain it, I guess, as it goes, maybe. Let's bring this up as primitive. Okay, so one thing that the renderable has that we didn't do here is this vertex function has a hard-coded shader name for the vertex and the fragment, and we don't want that. We want the renderable to be able to set it based on whatever the heck we want it to be. It shouldn't just be basic vertex function. This shouldn't be hard-coded. So what we're going to do is inside here, we're going to say var fragment function name string equals string, and then just like get set. And I'm not going to think about this too hard. I just want to kind of get this. Boom. And then we're going to have var. Oh, what am I doing? Let's put this down there. Var vertex function name string get set. Yeah, we have so many refactors because I kind of want to explain what I'm doing, and it's nice to kind of start small and then build on it. But I don't want to get too far ahead of myself. So we'll have a vertex function name and a fragment function name. See that? So these guys are going to have to move over here. In fact, basically what we're going to do is this build pipeline state will work for every single renderable. Will have to build a pipeline state in exactly the same format using these exact things. Like that's just how renderables work. They use the pipeline state put out to them by this vertex and fragment function. The whole idea of the pipeline state is to hold this vertex function and this fragment function and render things with them. Oops. And so that's what we're going to do. We're going to have everything just do its own build pipeline state. So what I'll do, I guess, is just go extension build pipeline state. Oh, what am I doing? Renderable. Easy. All right. Got a lot of energy. Ready to go. And this will just have func build pipeline state. And it will take in the device. Should it take in the device? No. Yes. Same exact thing. So we can just copy it. It's like boom. Taken, put, and now we like we can just call build pipeline state, but this doesn't extend it yet, so we'll have to do that. This is wondering what the hell is going on. See how this, so the render pipeline descriptor that we create right here, we'll have to set its vertex descriptor, so we'll need that over here, var, well, yeah, I'll put that there. Var vertex descriptor, mtl vertex descriptor, that get set. This is just basically properties on this. These work as properties, and so you know, everything that's a renderable will have to conform to this protocol. And so I'll have to put a vertex descriptor in my primitive and a fragment function name in my primitive, and then it will be get. Yeah, and these are just write properties. So can I get it? Can I set it? If I just put get here, I can set it at the very beginning, like right when it starts, but that's it. And then I can't set it again. So, which might be a good idea for the vertex descriptor, but I'm not going to worry about that yet. I'll fix it later. I don't want to think. It's too hard to think. All right, so these guys are going to have to come out of there, come over here, boom. So the vertex descriptor is in here now. The render pipeline state, oh, there's no render pipeline state. And so we're going to have to do that. We're going to have to make that. So var render pipeline state, mtl render pipeline state, get set. And this is going to be a little different. So we're going to say let render, well, yeah, let render pipe, I'll just put pipeline state, mtl render pipeline state, and then I'll put pipeline state right here. So we're actually setting it. We have to set our own pipeline state. So I'll put and then I'm going to return. So this is going to return pipeline state, because we have to set this. We have to set this pipeline state in here. We have to say my render pipeline state, not the protocol's render. Like I can't just set a random one. So I'll have to return an mtl render pipeline state, and then I'll just return this pipeline state. It's like so. I think. I hope. Yeah. Come on, IntelliSense. You got it. Yes. All right. Cool. So now we got that. Now, what are you talking about, dude? Constant pipeline state used before it's been initialized. I don't know if that sounds. Okay. That's not okay. I'm not. You were initialized right here, you son of a bitch. Oh. I mean, I could. Let me try this. I don't know if this is gonna work either. Live coding's fun. Oh man. I have to return you though. I mean, I could return this, maybe. Something like that. Is that something I could do? Making stuff up. I'm trying to remember how I've done this in the past. So I'm returning this one. It's been initialized right there. What if it hasn't? Can I do that? Would that work? Oh, sure. Oh, does this work? What? My cap in there the whole time? What? Okay. Yeah, it's like, screw you. This doesn't make any sense. Let render pipeline state equal I mean, I don't know if I can even do this. I'm just seeing if it allows me to. And then this says catch is unreachable because they're not. See, that's why I should be able to just set it. I mean, I could set it equal to nil. But that's gross. And this right here would have to be. Oh, was that it the whole time? Oh my god. I need to. Okay. Will you work? Will you work? Come on. Come on. Come on. No. Screw you too, pal. Let's try that again. Equals nil. Render pipeline state. And we'll just go like it said to do. And this should be cool. Everyone happy? Because I set it to nil. It set it to nothing. Then it'll print this. Return nil, if anything. All right, so cool. Build pipeline state. Done. Done. So I'm going to actually do this right now. So we're going to go to the bottom of the class of our primitive, and we're going to go extension, primitive, and then we're going to extend the renderable, and then I'm not going to do anything here yet. That's going to be our draw function right there. But since it's going to yell at us because we haven't conformed to it. We need all of these properties. So I'm just going to copy all these and put them up here at the top. So it stops yelling. Render pipeline state. We already have that. Just ignore all these errors. The errors are a lie. Vertex Descriptor. Yep. Well, we haven't made that global yet. We will. Because we say Vertex Descriptor right here, but we'll do that better. This will just be a string, and this will equal nothing. To ignore that. Equal. Yeah, we'll just put it there. Just do it. And then we'll need our step stencil state still. Actually, we're going to take the. We're not even going to do. Depth applies to everything in the application, not just this one primitive. So this shouldn't even be here. I don't even know why that's here. Super.init. So we need to say what the hell these things are. Vertex function name. So I'm going to go vertex function name equals this guy right there. I mean, it's hard coded for the primitive now, but okay, that's happy. So now these can just be set to the vertex function name. And then once it calls init, it'll work. It'll use these, the ones that we set, function name. Perfect. Perfect. And are you happy? Really? No, you're not. You're not happy. You happy? And now I need to call build pipeline state, which we're already doing, build buffers. I'm just going to run this, see what happens. See if it breaks at all. What are you doing? My cat's on my desk. Things might get interesting. See if our cube's still rendering. We're using this build pipeline state now. Oh man, suspense is killing me. Oh, we're gonna break. Oh, broken. No, pipeline state. Okay, so render pipeline state is nothing. Why are you nothing? Oh, because I didn't set it. So render pipeline state. Remember I said it returned something? It's because we have to set our render pipeline state to what it is. See that? So is how we set that guy. That's why we returned. Oh, more breakage. All right. What are you doing? What's going on here? What happened? We were trying to get this vertex function, but no vertex descriptor was set. So can you please do that? Yeah. So now, I shouldn't talk like that. I'm not going to talk like that anymore. You have my All right, so we have this vertex descriptor. We need to set it. Yeah, we don't know. It doesn't know what the hell the vertex descriptor is right here. It's like, dude, I need a vertex descriptor. Oh, it's right here, but we never set it. So let's get rid of it. Oh, and it's also, we need to get rid of this. So the way we're going to do this vertex descriptor stuff is, there's our vertex descriptor. I'm going to take it down a notch. Take it down a notch. Put it right there. I don't know if I said I wasn't going to talk like that. Oh, somebody sounds like they just fell down the freaking stairs. I think, trying to think. Yeah, no, so you gotta do this. I don't use the syntax that often. Then like this, and we say let vertex descriptor equal vertex descriptor. Right? And then we set all the vertex stuff. I think. I hope. Doesn't work. Doesn't work. Get rid of this pipeline state. We don't want to use that anymore. We want to use our other one. So this will allow us to set this, and we'll need to return it. So when I ask for it in here, it knows what the heck I'm talking about. Run. Build. Failed. What are you doing? What's going on? What? Vertex descriptor? What are you talking about, dude? Dude, what are you talking about, dude? Primitive does not conform to renderable. Do you want to add that right there? No. Oh, because I need. Maybe I'll just do this. Sorry. Nope, still broken. Still telling me to go to hell. Does not conform. What do you want from me? What do you not have? You have render, vertex, fragment, depth. Oh man, I cannot wait to move you out of forever. We have a vertex descriptor. It's fine. What are you doing, dude? What do you want from me? Let's see. Primitive. I think he's stoned. So what's up with this? All right, vertex descriptor, MTL vertex descriptor, right there. I have it. Everybody happy? Okay, get rid of set. We're only getting it. We're setting it right here. Is that really what it was? Come on, cube. Good cube. Good boy. All right, so there's our cube. That is our cube. And cool. Cool? Building pipeline states separately. Okay. Now this, remember I said build depth stencil state? I'm going to change this. We're going to go, this should be on everything. This should be in the renderer, because the renderer should be setting the depth stencil state. So I'm going to do all this depth stuff at the very beginning where it should be. Why in the world would I even put it in the freaking primitive? That doesn't make any sense. I just wasn't thinking. I probably had some stupid excuse as to why I put it there. We're going to build the depth stencil state in here. And then basic scene, build depth stencil state device. Okay. And then we need this command encoder. I think we set it down here. Yep. All right, command make buffer, command encoder. set the depth buffer. Cool. So that'll work exactly the same. Nothing changed there. Pretty cool. We just made it so that it's available for all of our different types, not just our primitive. My foot's falling asleep. And that will do that. That will do that. Okay. The next thing we're going to get rid of is, well, this garbage shouldn't be here. That should be a node. We should have that. We should, we'll work with that. We'll get to it. Model constants, that's okay. We're okay to have that in, that might need to go to node 2. Sorry, thinking, maybe put that node. We have the Vertex Buffer. This stuff's getting built still. Okay, so the only thing we'll need to do now is we'll need to make it so that we have a draw in our, oh, we don't need this anymore. All right, so I'm just going to make sure it builds with all of our moved code. See, now we have this renderable that we can reuse over and over again on different types. All right, with different like shaders, which is cool. Yeah, cool. So it works. Then we'll have renderable. Now we need to draw. So this render, like so we can render. Render's fine. Like set the render pipeline state. That's cool and all, but we need to go back to our renderable right here, and then we'll need to create a draw. So var draw stuff, draw pictures, I'll just put draw. I don't think that's going to break anything. And then we'll take in the command encoder, MTL render, MTL command render command encoder, render command encoder, and this will be a funky, and then it won't need anything, I don't think. Yeah. So now it's just gonna say go to hell. You don't have a draw function, but we will right here. Don't even trip. All right. Func draw. Command encoder, MTL render command encoder. Look at that. Are you happy? Yeah. So now everything right here will go in there. So we'll set the vertex bytes right there, vertex buffer, vertex bytes, etc. I don't know. I don't think we need vertex buffer, vertex bytes. Vertex buffer, vertex bytes. No. Yeah, because we might not use like this index stuff. That's kind of why. Let's put it in here. Okay, see what happens. Set render pipeline state. I think I should put that in here. That means we don't even need this render anymore. Yeah, we don't even need that render. That works. If it works, I don't know if it's going to work. But you see now this primitive, so we're not drawing ever. We never call this draw. So in our node, we need to go. So after we've kind of done all these children, we need to go, okay, for child as renderable in children for let child as renderable. Is that what it is? I might need to look this up. Like, oh shit, I cannot remember. For casting in a for loop, maybe. See, so we want to make it so self. So basically, I want it to cast as a renderable, and I can't remember how to do that. I'm trying to think. Might need for child and children as renderable child.draw. That'd be awesome. Let me see if that breaks. Oh, it does not conform. So can I do that? Should I? Can I? I'm gonna get it. Hold on. Give me a second, guys. So the node. So if sorry, I might need to look this up. I have another file I think where I did this. Alright, yeah, let me see if I can find this file. I want you guys to look into my stuff. Where did I put you? Let me try this. Oh, came over here. Okay, let me see. Yeah, I've done this before. If let renderable equal, I'm still as renderable. So I'm checking to see if I can cast myself as a renderable. And then I can say renderable dot draw. Boom. See that? Command encoder. That was way too hard. That was way too hard. Okay. So now that I'm calling draw, so it'll go through all my children and render them, and once it's done with this loop, it'll break out and then draw itself if it's a renderable, which primitive will be, because I add primitives to the scene, so maybe it'll work. I think this will work. I'm pretty sure it'll work. I gotta remember that syntax. If let renderable as, I knew I wasn't iterating through my children again. Yeah, so it's drawing if it is a renderable. If it's not a renderable and it doesn't conform to renderable, it won't draw. So we're only drawing our renderable. Now, so that's cool. That's awesome. Let's get rid of all this stuff. I don't want to do that. And then it'll probably be in our basic scene that we're doing all this rotate nonsense. We're going to change it. I'm going to delete that. I'll probably put it back again later. As a matter of fact, I'm just going to comment it out. Comment it out. And then we don't need this translate stuff. So let's just see if the cube gets added. Yeah, it succeeded. And the cube will be there. It'll just be face to face. Well, it's like super zoomed. Okay. So cool. Add child. C, add the cube. And now we want a way to translate the cube, rotate the cube, and basically that's done in the model matrix. So our node realistically should have this model matrix. And so I'm going to create that var model matrix as a float. Mat float 4x4. This guy. And I'm going to do exactly what I did before. And I'm going to return our model matrix. So I'm going to say let model matrix equal let model matrix equal. So I need to instantiate it. That's what it is. Sorry. Okay. Var model matrix instantiate as equals matrix identity float 4x4. So I'm gonna make it an identity, and now I'll do all my transformations. So like blah 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 blah. Node will have, so every node is something that can be put on screen or something, or so we'll give it a position. So var position, which will be a float 3. This will actually, let's do this, equals float 3 0 0 0. Var rotation equals float 3 0 0 0. And then var that's position. So you position, rotate, scale. Var scale equal, well, why am I doing that? Float 3 0. We don't need to put all the zeros. We can just put 1 0. And that equals 3 0. Equals float 3. But this will be a 1 because we don't want to scale by 0 first. Because if we do that, then yeah, like we don't want to scale by 0. We'll be disappeared. We won't exist. We'll scale to nothing. All right, so now we can just say model matrix dot translate in the direction of position. Okay, and then we'll say, and you'll see why we're doing this. Model. So it goes translate, rotate, scale. Right? Yes. 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 I hope. Yes. Model. Yes. Matrix dot rotate. Now I said you can't rotate around all axes at once, but that's good. So now we can use our rotation dot x and then just rotate around a float 3 of 1 0 0, and then we're going to do this 3 times, and we'll just do one around, like rotate around every single axis. So we'll go around the y-axis, around the z-axis, and then we'll just change this to the x-axis. Oh boy. And then we'll change this to the y-axis. Axes. And then we'll need to scale, so model matrix dot scale. Axis will be scale. Cool? Maybe? And then return, obviously we got to return model matrix. Let's make sure that works. Okay, so now we will have a model matrix for everything. Cool. Now let's try it. So let's make sure it builds, like always. I kind of like to do that. If you haven't figured that out, well, I like to build. And so we get this guy, yep, and now I want to translate the cube back. So q dot position dot, let's say z equals -7. See, now I can just set the position like that. Pretty legit, if you ask me. Move back. Okay, didn't work because I'm not setting the model stuff. So we're in our, I think, node. I need to set this up. I need to set it in the command encoder, I think. Yeah, see, now we have our model matrix. Oh, it's in our primitive. Yes. So you have these model constants, but I'm not setting them anywhere. They're not like, I think set vertex. Let's do it right here. Model constants dot model matrix equals model matrix. See, now I'm setting it to myself because I'm a node and I have a model matrix, and now it's going to jump into model of constants, and yeah, cool. So we can like translate, rotate using that. So we can say like, oh, the dot x or the dot y, or we can even set it entirely with the the float, like float 3. So that's kind of cool. Let's just kind of rotate it just to make sure that we're rotating correctly again, because I like to do that. I like to rotate c dot rotation dot x plus equals delta time. Maybe you don't want it to equal delta time because that's a constant. And we should just be like, oh yeah, look at that. Looks like it's cooking. We put a little fire right here. Oh man, that's gonna taste so good. Colorful rainbow cube. What do you want? Man, my cat is so cute. You want to see him? I'm not gonna show him to you. Yep, I'm gonna show him to you. Here we go. All right, come here. This is my cat. He likes to watch me code sometimes. Say hi, Gretch. All right, that's enough of that. Yeah, he's better coded than I am, to be honest. Okay, little cameo. All right, so and then I have another cat who's evil. That was me. Yeah, refactor. Done, I think. Let me just go through this. So now look at our primitive. It's only things that primitives can do. Our primitive will have vertices, indices. That'll probably be a lot of things, but sometimes they won't have indices, you know? For the most part, they'll probably have, like, everything will have vertices. But that's okay. We don't need to worry about that right now. No. Get out of here. Shoot. Shouldn't have left the door open. This is my bad. Get out of here. Build vertices, build buffers. Okay, Vertex Descriptor. Okay. You guys see I'm busy? Yep, so that's that. So now, I want to get into some freaking lighting. Actually, yeah, first thing I want to do is go back to my metal view. And, so there's lighting I want to get into, but in order to, like, kind of prove that we can do some lighting, and it's not even lighting, it's like fake lighting, because I saw this in a video a long time ago. It was with OpenGL, but I wanted to apply it on here, and I cheated and looked, like, kind of calculated some math already. There's two different types of, I'll get into that in a second. First thing we're going to need is we're going to need input, user input, and the one thing that I want to do is the mouse, like moving of the mouse. Now, since this is our metal view, no, we'll get in the mouse, I promise. But I want to do something else that's kind of cool. So, sorry, let's move you up. All right, so let's go to main storyboard. Okay, we're gonna zoom out. I hope this is zoom out. Can I use this? No, that didn't work. That didn't work either. View. I want to zoom out. Okay, there's probably a zoom button that I don't know about, and it's really freaking easy to find. Anyway, so this is our view right now. It has this view controller and has this window. Now, we don't want this whole window to be a view because we want to put some buttons on there. Because I want to put some buttons on there for at least your sake, for learning, and for my sake, for checking stuff out, for debugging. So let's do that. If we go here and open up this little guy, and we go here to the... You see, we have this class metal view, and the metal view works for any window. So this window could be anything. And what I mean by that is let's go ahead and turn this not into a metal view anymore. We're just going to call it NS view controller, right? Right? No. No, can't do that because I need to first make the class. All right, I'm going to turn it in NS view first. And I'm going to play, and I'm going to see if it builds. It should build. It should just open a window. Yeah, see, now we have an empty window with nothing in it. Our metal view isn't in there, but that's okay. But what we want is I want to make this window have the capability that controls like these like check boxes and these buttons and stuff. So what I'm going to do is I'm going to convert this window into an NS view controller, and then I'll be able to add button clicks and stuff. So let's go ahead and go here, and I'm going to go new file. It'll be a Coco class. Next, I'm going to say view controller, and then NS view controller. Don't do that. Do this. I'm going to add it to this file, and this is just going to be the view controller. I know I deleted this in the beginning. Don't delete it in the beginning. I'm silly for that, but that's okay. Now we have this view controller. Let's go to our main storyboard. I'm going to put this right here. I'm actually going to create like a window group, I think, because we got a couple of things that could go in a window. I'm going to do that right now. New group. Window. We can go in there. You can go in there. Metal view can go in there. Renderer can go in there. And shaders, types, renderable. This is more of like a node. Not really. I don't know what the hell to call that. This could probably go in the shaders class. I don't know. That's good. Now I can just separate it. That's all I want to do. So now I have this view controller. Let's go into main storyboard. Let's go here. Let's go view controller. Okay. All right. Well, you know what? Okay. I broke everything. What am I doing here? There it is. Okay, so you gotta click on this up here. And then you can type it in. Now, watch this. Oh, watch. So, and also down here, do like, just type custom. And they'll have this custom view. You can make it whatever the hell you want. And we're gonna type metal view right there. So now it's a metal view. And let's press play. See what happens. I wonder what's gonna happen. Well, we have an NS window and we have a metal view inside here, so what's gonna happen? Oh, look at our freaking little tiny, look how tiny and cute he is. Look at him, he doesn't bind to the walls or anything, he just sits in there and he's cute and he's rotating. Isn't that kind of cool? We can add like a million of these all over the place. Like, I just want to do it. I know I've got to get going pretty, I don't care. I'll get to your thing, bro. Don't trip. Like, we can add these all over the place. And we can actually make these do different things based on input, which is pretty sweet. See, we can just keep adding these all over the place. We're not going to do that. We only need one, because for now at least. But we're just going to put you in the top corner. Actually, I don't even need to do that. What I'm going to do is I'm going to add these constraints. 0 here, 0 here, 0 here, and you're going to be like 15. You're going to be like 30. Yeah, add 4 constraints. We're going to make you a little bigger. This will be 65. And then we're going to have to go here, and we're going to go here. Where are you at? What are you doing? Add. Click in here. There we go. Okay, sorry. I'm trying to figure this out. What's going on? Oh, it's because I didn't have this selected. Select that. Go to here. And, yep, so all of our constraints look good. Let's build this. I just want to make sure that we have some space at the bottom to add. Well, I only want to add one thing right now. Yep, and so we have this little space down here, and when I make it bigger on the bottom, it doesn't. When I make it on the side, it doesn't. So it obviously just got rid of all my gosh darn constraints. Drag that up. Right there. If you know what you're doing, good for you. You're a champion. I, however, am not. I'm going to make that 85. Add 4 constraints. Done. Press play. See what my time is. Man, time flies. Cool. So now, if I make it bigger, let's make it like full screen. Oh, big cube. Not resizing correctly. Elongated cube. The aspect ratio is wrong. That's all. We'll fix that. But now we have this little space down here that we can add little clickers to, little buttons. And I'm going to do that. I'm just going to add a checkbox. Checkbox button. Checkbox button. A checks mix button. It's right there. I'm not going to say check. It's going to be wireframe. Because what I want to do is I want a button that adds the wires and makes it not solid. Shows me the vertices and which lines are drawing. So that's what this checkbox button is going to do. Now, when I click here, this should be... Oh, well, you're wrong. View controller. Yay. And I'm going to hold down Control and drag. So I clicked on that while holding Control and drag to here. And I need to type in we'll say check wireframe. It's kind of just a naming convention. Put that guy right there. And then we're also going to need a clicked event. Oh, do not hold Alt, hold. We're also going to need a click event called check wireframe underscore clicked. And then this won't be an outlet, it will be an action. Type will be, whatever, connect it. So now we have this checked, and so what I can do is I can just go swift.print. Just want to make sure this works, by the way. That's why I'm doing this. I don't know, if you know iOS or OS X development, you're probably better at it than I am. I know the simple adding controls and what is not. I'm getting a call. I will say that. Decline you. So hello world, we're running, yeah? Yeah, it's back there. So now if I click this, watch down here. Pretty sweet. All right. Stop you. So we're not going to do hello world. What we need is we need to update the view. And how do we update the view? But doing this. So underneath wireframe, actually at the very top, because this is like the most important, we're going to put metal view, main metal view. This won't be a button. Wait, what am I doing? No. Do the view. Do the view. Yeah, now it's a metal view. And I'll say main. I'll put mtl view main. It's all good. Looks kind of dumb. Can I put window? Metal window. Metal view. Main metal view. Sorry. Main metal view. We'll just do that. And storage, weak, connection, blah, blah, blah. Yeah, blah, blah. Now I can access the main metal view. Can't I? And so if I go to my metal view, I can say metal view dot whatever functions I put in here. So func toggle wireframe. Right there. And then we'll say boolean, wireframe on bool. And then we'll do whatever we want here. So now from my, I know I do that all the time. Window, God, that was too hard to find. Okay, so now here I can go main metal view dot toggle wireframe, and I pass in like whatever it is. So we have check wireframe dot, oh, I always forget this. Enabled? I might need to Google this. What are you son of a gun? Dot is on. Dot. It's not enabled. No, because that means is it enabled? Dot selected. All right, I'm just gonna go through it real quick. Let me see. So dot image is border is included. State. Okay, so and then we're gonna have to make that a boolean because it's gonna give me 1 or a 0. So I can just say bool like that. Cast that as a bool. And then over here, say Swift dot print wireframe on. Sorry, I have to do this. This is super duper important. But you'll see that we can call this function of boolean. How do you cast things? Oh no, I code in VB.net as bool. I think that's how you do it. Let's try that. Nope. You should go to help. Type in bool. Like this. Boolean. I might have to look this up. Sorry, peeps. I'm gonna do it. Cast. I do too much .net. So cast boolean or cast integer boolean Swift. Bool number as ns number. Whatever, dude. This is why it's confusing. You see? So we're gonna go like that. Bool wireframe.state x. So you had to cast as a number and a boolean. So I almost had it. So the ns number can be turned into a boolean, not just a state, which is just a number, integer. So this should work. Now when I call toggle wireframe, see we have true, false, true, false. See that? So it's working now. So now I'm going to go like this. And then we have this renderer. So our renderer will need to also have functions. We'll probably make this a little easier in the future. But the renderer will have func set, set toggle wireframe. I'm just going to call it the same thing. Sorry. Wireframe on bool. And then right here, I'm going to say scene bar wireframe on bool equals false. It's going to be false to start. And then I'm going to say wireframe on equals self.wireframe on equals wireframe. If you have questions on what the hell I'm doing, please ask. I'll respond. You cannot do this, tutus. You know why? So I don't know what that means. You know. Give me that. You know. What are you doing? Oh, God. Everybody happy? Now, I can use that down here. Remember last episode where I did the wireframe? Well, set depth sounds blah, 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 but I'll say if VB wireframe on, I can go command encoder dot set triangle fill mode dot lines. Right? Let's try it. Oh. So now I'll have like a cool little input thing that we can put on the windows. Maybe we put some sliders, maybe change some colors. I don't know. It's just kind of nice to have. And obviously it doesn't work. Am I ever hitting this? I'm just gonna. Oh, because I don't even call it. Do I call it? I never call it. It won't ever hit there for the rest of the time. Because in my metal view, I don't say render dot toggle wireframe on. Cool. And since it's false, it won't be on to begin with, and then it'll set it to true. We could probably do whatever we want, but since it's false, and now boom, and, oh, okay, now it's inverted. But how cool is that, huh? It's on, off. So let me. And here, what I'll do is I will say this exact same thing. I know, that's ugly. Oh, screw it. It's just setting the initial state to whatever our checkbox is. So if it's on, it'll be on, off. You see that? So what I can do is do that, and then I'll go to my main storyboard, go to this guy, and just set its initial state to, where are you? Enabled, off. I think that'll turn it off. No, not enabled. It's checked right now, so check style, check, yep, type switch, state off. There it is. Yep, so now it'll use the state on initialization to set it off, and then this will just handle the action click. And now it should be nice and filled, and then we can check the wireframing mode. Oh, so legit. Right there. Look at that. Oh, that's sweet. All right, and now we can put like sliders and stuff down here too. I'm just going to do one quick thing because we don't need all that space yet. I might move it up in the future. That's a good spot. Put that wherever the hell you want. Put it up on top if you want. Let me just make this look good. So update constraints. And then I'm going to constrain you. Oh yeah. To that. I'm not going to do that. Yeah, that. No, because then it'll stretch. So I'm going to put it to the side and the bottom. and add those two constraints. Now let's see what that looks like. So it'll be on the bottom, but this is also attached to the bottom, so it shouldn't actually look weird. It might look weird. Yay! Yep, see, so now we can do that. The elongation is going to happen. I mean, we can probably go do that. So back in our metal view, see, this is kind of like a refactor of everything. Back in our metal view, renderer, our delegate, see this view delegate, we have this drawable size will change. So as we update the screen size, we should probably update the aspect ratio. Because right now I'm just passing in 1, I think, is the aspect ratio to the scene dot, our scene's aspect ratio. Let me see, scene dot swift. When we do our projection matrix, we just pass in aspect ratio of 1. That should be width over height. And so what I'll do is I'll go var aspect ratio as a float equals 0.0. Well, I'll put 1.0 just in case it's ever something. And then from my renderer, from in here, I can say scene. Oh, well, no, right here. I can go scene dot aspect ratio equals view dot bounds dot width divided by view dot bounds dot height. Now, this will need to be a float so everyone's happy. So these will probably need to be floats. So it's a float divided by a float, not a double or whatever the hell that returns, probably like a CG float. So now the aspect ratio is updated, and so instead we can just use this aspect ratio in our scene. And let's just try it. Let's see what happens. I don't know if this is it height over width? I think it's width over height. It's like 3/4. So height over width. Height over width. Yeah, let's do height over width. Oh, and then I need to do it initial. I need to do an initial. So we have metal view, or no, we have renderer, and let's do height divided by width. Usually you like to keep a 3/4 ratio, so like 960 by 540. It's like 960 by 540. Is this wrong? Oh, boy, oy, oy. Let me just make sure that it's. I know I can debug. Don't tell me what I can and can't do. Rebuild. My computer gets so loud. Hello, work now. Oh, look at that. It's okay. So it is working, but for some reason my projection matrix isn't. Oh, it's not updating it every single time. But and we can totally do that. It's not too much work. So I mean, it's kind of important. I mean, we could actually add like an if did change. We only set it. Where do we set it? We set it in our scene. See right there. So instead of doing it right there, we just do it here. Do this, this. Set the scene constants, and then we can kind of update our projection matrix as we go. This doesn't take too much time. If it does, I'll figure it out later. We'll figure it out when we do some debugging. Yeah, so now it's working, but I totally have it inverted. Thought so. I thought so. Let's go back to our renderer class and invert these guys. So width, I knew it. I hope this works. If this doesn't work, we'll figure something out. I'll just use one. But, oh, yep. So this is actually legit. Look, it stayed the same size. It's not elongating. It's using and it's probably a legit cube now. Like it looks weird now, but it's a legit cube. It's using legitimate aspect ratio. Isn't that cool? It is cool. Let's not zoom out so far so it's like right up in our face. Just change that, so like -3. And then what we also could do is, so the projection matrix, we can mess with that. So like we can add sliders and stuff in our view. You can add sliders if you want. I don't care what you do. That's way too close. That looked ridiculous. I'm just gonna do a -5. I think that's where it was before. I'm just gonna keep it there. It's fine. Yep, so this is kind of closer. But you see, now we have this, and boom. Now it looks like a legitimate cube. It's using really good aspect ratio. So that's all up to date, so we can start coding a little bit better. This position, rotation, let's, cool. Yeah. Now, I promise, I said we'd do some lighting, and I'm not turning back on that. Oh, his gig started at 6. Oh, man. We're going to do some lighting. Now, just a little bit, just to kind of get some pointer input. All right, so in our metal view, okay, this is going to get a little tricky. I actually put a little bit of code over here because this is, I really had to research this. So we want input, right? We want it to know that when when we move our mouse, we want it to update the position at all times, so we constantly have a location of our mouse. Now, you could do mouse click, get the position. You can do anything like that and get the position, but the problem is if you click over here, or it'll return what this 0 is over here rather than here. And so what we want to do is we want to create a tracking area for this mouse, okay? We want to create the tracking area so it uses this view and gets that 0. I actually don't know if this is going to work with this. We'll figure it out. But yeah, so it's self. Yeah, that'll work. So we want this to be 0, 0. We don't want like this over here to be 0, 0, because then it'd be really hard to do calculations based on where the screen is. You know, we don't want to do that. So let's go ahead and do that. It's called an NS tracking area, and I'm just going to copy paste. And you can copy. Yeah. So I'm going to do it at the very top. Right there. So let me close this so you can see it in the full line. So, get rid of this. Okay, so what we have here is we have this area. We're declaring this area of this the screen, right? And we're saying the self.bound, so it's giving you the width and the height of our metal view. And then we have these options. It took me a second to figure out which ones I needed, but we always want to be active. And we're going to pass, this options are kind of a dictionary. So this is the key, and this is the, well, never mind. I thought options were a dictionary. I think they're a dictionary. I could be making shit up now that I'm talking. But we want it to be active always. We want it to do it on mouse moved. So it's actually hard to freaking get mouse moved to work without this. And then we also want enabled during mouse drag. So when we're like dragging our mouse, we want it to be enabled. However, there's one little small issue I've encountered in the past, and I'll try to fix it. Then we want to just add the tracking area to our metal view. Easy. And now we can just call func mouse moved, and you'll see it pop up. See that? Oh, that's so cool. I love IntelliSense. And then we'll say swift.print event dot mouse location location and window. See that? And now, since we have tracking, I hope this works. Override. Of course. Of course. But of course. See, we're using mouse moved right here, so it's using mouse moved. See that? And if we move, oh yeah, and look at 0. It's right. I hope it's not down there. Yep. And then it says 51. Oh, shit. Okay, so it's using this view as the whole entire view, I think. I was hoping that wasn't the case. We could always add 50, but I don't want to do that. That's kind of janky. There's got to be a way. There's got to be a way. Owner is self. I thought the metal view would be the self owner, but apparently not. because our Y is at 50. You see that? Oh, I want that button there. I want it there so bad. Like this looks like the X is 0 for sure, obviously. And it stops tracking outside though. See that? The mouse tracking stops. And it stops at 50 all the way. So that might not be good. We might need to, It's okay, because we could just, we have the number. We actually have the size of the window, and we can just kind of figure that out on the fly. For now, I'm just going to figure it out on the fly. So since we know if we exit out of this, we go to our main storyboard. We know that these bounds for this window are 16. It looks like 50. I'm pretty sure it's 50. We could just say dot plus 50. So, oh, that's such a hack. I've never done this before. That's such a freaking hack. Metal view. Okay. How about this? Dot absolute X. Let's see what else it has. It could just be dot. I'm going to see what absolute X returns. If it returns 0, 0, and whatever, I'll be really happy. Don't think it will. Well, I mean, it should have been Y. I should have checked Y. Yeah, see, that's not going to return jack shiznit. Location and window. Oh, I'm so upset. Dot. I'll look online and try to figure out how to fix this better, but plus, let's say 50, and then we'll say Y. So Y plus, comma, event, dot, locate. I'm going to figure out how to fix this, guys. Don't worry. Next video. X. Okay, so now we have plus 50, or minus 50. It should be minus 50. Binary expected separator plus. I think it's minus 50. Yeah. We start at 50. And that should give us something, I hope. What are you doing? Cannot, oh, gee willikers. Okay, so how do you do this? You do this, I think you go that, surround all of it, then you go like this, like that, or, yeah, this, starting to get into some stuff, people, right there, right. Okay, so let's go down to the Y, and we are at 43. Why is that plus sign in there? Oh, because... You silly. We don't need that. We can just put this. There. I don't need a plus sign. We're not concatenating. This isn't Java. Alright, so freaking 366. The hell? What are you doing? Oh, dot X. This is dot Y. Minus 50. Sorry, guys. We're going to get this over with, I promise. Dot X. I bet you someone was looking at that already. One of you guys, one of you smart little geniuses. 0. It's going to 0, I promise. Alright, so, and 0. I just hope the pixel location is, yeah, I'm pretty sure the pixel. Yep, so it's about 0, 0. That's exactly what we want. Now that we have that, we can update the mouse position. So I'm just going to say, let X float. I know there's probably a calculation we don't need, but I'm going to do it anyway, just because Why not? For now, it's not like we're doing super optimized stuff. We're just kind of learning the basics, and then we'll get into it. Let y float equals float, and we're going to pass in this y. I know it's so freaking hacky. I'm going to figure it out, boys and girls. There's girls out there. That'd be kind of crazy. Good for you. Pick up programming. All right, so y minus 50, and then we're just going to update our renderer that mouse position. So our renderer needs a mouse position, so var mouse position, and then I might move this somewhere else too. This is going to be a float 2, and then that'll be 0, 0 to start. Yep, there's that. Now we can just update that. So we'll say in our metal view, we'll just say renderer dot mouse position equals float 2. We'll say x, y. There we go. Now mouse move gets updated. See that? Beautiful. Now, now since we have our renderer has our mouse position, pretty cool. Right here, we have our mouse position. Now we can pass that to wherever the hell we want. See that? Bueno. Or scene. Okay. Let me think. How are we going to pass this? So what I want to do is I want to make it so that we move our mouse. There's like, it looks like there's light. And so I could apply it to the scene. And you know what? I'm going to go back here real quick. Let's probably stay at 0, 0. I'll fix that at some point. I just want to kind of move on. I got to get off. Let me see what time it is. Okay, we're good. We're good. We're almost there. So scene.render, we want the light to be on the scene. So what I want to do is I want to create a new type to pass to our GPU's fragment shader. So types.swift, we're going to go struct light, and then we're going to say var light position, and that will equal float 0, 0. 0.0. I think like sometimes it has data issues where if you use just 0, it might be an integer. It's weird. Equals float 2. Float 2. Yeah, but that's beside the point. If we run into that issue, we run into that issue. I'll just need to make sure to cast everything. And then our scene will use that light, and all of our scenes will have light, or an array of light, whatever we want. So I'll say var light equals light. And so I told you we're going to be applying it to our fragment. So we're going to want to set some fragment bytes. So command encoder dot set fragment bytes. And we're going to apply the ampersand light to it. Memory layout of light dot stride at, I don't even know what number it is. Let's go to our, there. Looks like just 0. This will be 1. Let's put out 1. Cool. 1. Right there. So we're applying the light to there, and now I need to go into my shaders and do that. So now we'll have a cool constant space, constant light, the reference of light, and pass that into buffer 1. But we also need it to be a light. We don't know what light is here, so we need struct light, light. Oh, we got float 2, light, pause, boom. Okay, so now we're passing into our fragment. Okay, so this, it's going to get a little complex because the formula is a little bit higher than where I am right now. This, like, I know what it is, but it's higher than what we're showing you right now. It's just kind of, we have the basics. This is fundamentals kind of a deal, but we're gonna do some length, some distance calculations. I did this. I don't know why I did it. They are distant. This is, anyway. What a goose. All right, here we go. So, everything should be good. All right, I'm going to run it. Just make sure nothing's breaking. We should have a cool little wireframe button at the bottom. We have this wireframe button down here. I guess it's still doing this thing. Funny. But our wireframe button works. It's tracking just right. In fact, metal view, this is in renderer. And then, no, metal view. Renderer does the draw. This, we don't want that anymore, but we're updating the aspect ratio now. Also, just thought of this. When we resize, remember, we set this area, this tracking area right here. We're going to want to keep doing this. We're going to want to update this. See that? Yeah. Oh, yeah. Yep. Just thought of that. Okay. That's okay. I'm just going to say func update tracking area view mtk view. I don't know if this is going to work. And we're going to put this there into our renderer. This will be self. This will be view. View.bounds. View. Okay, so now every time we resize, we can just say update tracking area with the view. Okay, so that's good. Now, because it'll resize, and now we can just call update. Oh, well, we need to do it after we create the renderer. Renderer dot update tracking area self. Cool. Yeah. And then I'm gonna just put this swift dot print. I just want to see this at all times. Run it. Let's make sure that it's updating correctly now. And that I've done this update tracking area. I've never done this before. This is new to me. Alright, so here we go. So mouse position looks good. This goes all the way up to the top corner. It's 550. You go to 0. Okay, so that's updating. Now if we resize it to big, bigger, there should be still going all the way up to whatever it is. Actually 1,000 now over here. Damn, that's so crazy. A lot of pixels on this screen. All right, so now that we're doing that, cool. Let's pass in some Lord. So now I can pass in the light position. We're just gonna make that our mouse position. Yeah. Oh yeah. So this is gonna be our mouse. Light position is gonna be our mouse position. So in our scene, our scene will have a mouse position, right? No. See, our scene will have light. And so we can just call scene.light position equals light on every time, which is right. We'll just do this for right now until we have more of a functionality. So this, we're going to do it in the draw call in the renderer, and the renderer will have the scene. So we'll say scene.light position equals. All right, well, we're going to need to do some calculations. Like I said, this is going to take some, there's actually some things I want to point out, but we'll go let position x as a float equal view.get mouse position. Have I not written that yet? Var mouse x, no, mouse position This is probably not the best way to do this. All right, we got this everywhere. Render.mouse. We'll still do that, but I'll put. Oh no! You know what? I'll just put mouse position equals this. Then I'll call func get mouse position, which will return a float 2. Return mouse position, and then I can call dot mouse position. Now in the render I can call get the mouse position, and so I'll say let mouse position float 2 equal float 2 float 2, and then we'll say view.get mouse position. Oh my god, where are you? Where are you? What are you doing? Is this public? Doesn't it even public? Is that a thing? Passing in this MTK. Oh, it's because it's not a metal view. 3. I wonder if can I do this? Is that a thing I can do? We'll find out. I'm gonna do it down here. I hope so. Sorry, I'm quiet. I'm just trying to get through this. So scene.light position equals float 2. And we'll say pause X, pause Y, and then what I'll do is I'm even gonna I know they're already floats, but God, sometimes this sucks. And I promise I'm gonna go through this stuff when you're not looking and find out if we need it. But for now I'm just gonna play it safe. I'm gonna run it. Hopefully that draw works. I don't know if this draw is going to work. We might need to... what? Does not conform to MTK view delegate. All right, let's see what it wants me to put. Method draw. Oh, okay, yep. So it needs that MTK view. That's bullshit. It's okay. It's not the worst thing. Just thought of something. We can make this get public shared function, right? Right? The shared is that a thing? Not shared. Static VB.net, man. Public static function. Well, mouse position needs to be that. Well, we can do that. Static var mouse position. Oh, well, this, we can't, what is this? Oh, you mean, oh, perfect. Good. Now I can call from my view control, no, from my renderer. It's like, no, metal view. Boom. Yeah, you shouldn't be bitching anymore. Do not complain at me. Do not, oh, okay. Used in an instant, oh, metal view. Boom, works. Mouse position is updating. Cool. Everybody's happy. Bueno. All right. So now that we have this mouse position, and our renderer is saying, okay, we're passing it to here. Now let's go to our shader and use this light position. So we're gonna use something called length. What length does is it gets the distance of the vertices. So okay, so the way the fragment, oh, God damn it, I didn't prepare anything to draw, but I'm going to So the vertex function, let me see. The vertex function, okay, let's do this. How do you like potato? I love it. No. I'm busy. So what the rasterizer does, it creates this triangle, right? It creates these vertices right here. So, the vertex shader creates the vertices. So I'm a vertex shader, and I'm creating vertices right here, here, and here. Okay, I'm going to create these vertices. I go through the rasterizer, I interpolate these colors between each other, and I create fragments inside. So all these little fragments. I'm not going to do it. Okay, so we've already gone over that. I come out of the rasterizer, pixel by pixel, right? So when I say VN right here, not pixel by pixel, fragment by fragment. There's the difference. All right, so I'm gonna zoom this. God. Okay, so right here, when I say vertex in right here, it's taking in the vertex in, but it's taking in the position. So if this was a 500 by 500, this would be 0, 0. And all right, yeah, it's probably okay. So this is your really janky ass screen. All right, this position actually, in our case, we'll need to. The pixels start here, so we have 0, 0, and this will be 1, 1, but or whatever. We're gonna make it like this. 0, 0. Okay, we're gonna make it like that. It's not like that, but so say this point right here is 0, 0. This will be the width. Height of the pixels. That's height. With height of the pixels. So this could be like 1000 by 1000 or whatever. So when it gets the vertex in position, this VN position, it's really like the position of that one teeny tiny fragment. What is that position? What color am I coloring this tiny fragment at that one tiny position? So if I'm hovering over this with my mouse, right? So I have my pointer, and my pointer is right, right here, right on this dot. This is my pointer. Okay. I want this to be bright, so I want it to be bright right here, and darken as it goes out, right? Not in that was a shitty circle. But I want this to be brighter than this, right? So what do? I need to find out this distance right here between these two. So the distance formula, what it is it's the square root of x2 minus x1 squared, oh my god, minus y squared minus y1, not y squared, y2 minus y1 squared. So I guess the distance formula, and what it'll do is, okay, doing this. Just, you gotta know it. You gotta know what the hell I'm doing here. I'm not just gonna do it. I'm gonna say graphics stuff, graphics, tweet-time graphics. Mac OS, okay. We're gonna add that to, I guess, my desktop for now. I might change this in the future and put it somewhere. Okay, so now this is gonna run. So now I want import SIMD, import SIMD, because that's all the math that I need. So now say I have two floats. So I have var x equals float 2 equals float 2 of, say I put my cursor at 0, 0. No. Yeah, 0, 0. And I put var y float 2 equals the pixel position, which is float 2, which is like, I don't know, 2, 4. No, we'll do 1, 1. Just for the sake of argument. Okay, so now we have x and y, right? Well, if I want to get the length, the distance, I can just pass in length of x minus y. And that will return whatever it returns, maybe. Hopefully. Stop and play it. Because I'm impatient. What are you doing? It's probably just freaking out because this video is 4 hours long. Oh. Okay. So now I do length x minus y, and I'm going to have to go like let L equals that, and all right. I'm not gonna save this. I'm just closing this up. Maybe my computer will quiet down. All right. So now look at. So we have 0 to 1. We get 1.4. Oh, that's weird. You would think the distance from 0 to 1, 1 is 1. Well, no, because if you look, it was. I said it's the square root of x2 minus x1 squared. Blah blah blah. Let's just look at this. So the math. Let's just do the math. Yeah, I've got to open it up. Got to open it up. It's important. All right, so like I said, x2 minus x1 squared plus y2 minus y1. This is the distance formula. I think it might be minus. Oh my gosh. I've been talking for too long. Distance formula. Is it minus? It better. Let me see. Distance formula. Yeah, it's plus. I was right. Man, why do you question yourself? So this is the distance formula. This equals the distance. Oh, like how far is it away? Right? Between 2 points. So my first points were x2 minus x1. So 0 minus 0, which equals 0, squared equals 0, right? 0 to the power of 2 is 0. Plus, we have 1 minus 1, which is 0. So 0 plus 0, square root of 0, gives me infinity. Right? No, I did something wrong. So this is 1 minus plus, so 0. 0 minus 0 squared is 0 plus 1 minus 1 squared equals 0. So 0 square root of 0. No, it should be 1.4 is what am I doing? I can't see. Let me see. X squared minus plus? It's plus. Oh, is it plus? Oh my god, is that what I got confused? Yeah, that's exactly what 2 2's got. Alright, so this is plus, sorry. So 0 plus 0, 0. Plus 2, right? So the square root of 2 is 1 blah blah right here. This guy, this number. So this number, if we take, so this is the distance. It's 1.4. From 0 to 1, 1, it's 1.4. That's the distance. Now, if we want to bound it to 1, because our view clipping space, remember, is 0 to 1 and negative 1. But our pixels are 0 to whatever, like 0, 0 to whatever. Like the pixel number is way up here. But if we want to bound it under 1, from 0 to 1, we have to go 1 divided by, right? And so this will bound it to 1, and the closer I get, so if this was 0.9, or let's say our x position was 4, okay? And this position is 3. Watch this number. Watch this number. 0.74, right? But as I get closer, 3.9, and I'm really close, really, really close. Look at this number right here. It's going to go from 0.74 to something. Big number. Really bright, right? Because we're doing minus. Really, it should be 3.9. 3.9. We'll do it this way. Just give you 4. 4. Okay. So you see, I think we'll still get 7. Yeah, because it's squared. Anyway, wait for this number. So we get this big number, right? So that's bright. That's close. That's close. But if we go farther away, like 1, 1, you'll notice this number gets really small. Ready? Watch this number get small. Look at how small that is. And then if we go 1 to 1, I think it breaks. It's right on top of each other. So the farther away I get, it becomes, so if I go to 50, like way far away, like off, like way out there into the distance, like crazy far. This number becomes really tiny, but when I get really close, like 0.9, 0.9, this number becomes, wait for it, big. You see? So now it's like, all I have to do is multiply. So the intensity. So basically what I'm calculating right now is the intensity. So the intensity of the pixel color, right? I'm just going to say it because I got to get out of here. So it's not let intensity. It's var, float, intensity equals light, 1, and I'm bounding it between 0 and 1 because really you can't multiply a color times, 9,000. It doesn't make any sense. It would just come out to white. So why not just bound it to 1, from 0 to 1? Like, give it that gradient from 0 to 1. That's why we're bounding it. I'm sorry. The length of, like what I just said, of v in dot position minus, dot xy, because we don't need the z in this one, minus, because the light is only light position is a float 2, so we only need that, intensity. And so now what we can do, and also we're not going to return a float 4 anymore, we're going to return a half 4. I'll go over that in the next episode. This will return v-in.color. v-in.color is not a half 4, so we're going to say float color equals v-in.color, float 4, v-in.color times intensity. So now whatever color that pixel or that fragment is, it's going to be multiplied by whatever this is. And so now we will return a half 4 with color.x, color.y, color.z, color.w, which is just 1. It's like, what the hell is w, dude? That's not a thing. All right. So let's run it. Let's just see what happens. All right. I'm just going to see what happens. And I'm also going to fix something, maybe. No, never mind. We're good. So, does anything happen? Anything? Oh, what is that? Look at it. Oh, it's also inverted because remember I said, so this up here is 0, 0. We want this to be 0, 0 because the screen's pixels start down here. We also want our pointer to be starting down, or our screen's pixels start up here. We want them to start down here, so we're gonna have to invert that. But like, look at, we have a little bit of guy. All right, and also, so what we can do is, we can go times 50 or times 100. Let's make it really bright. So the intensity times, so we're gonna make the color times the intensity times like 100, and you see we get this really cool like effect. Let's fix this crap. All right, so there's 2 things that I realized in doing this in the past. Okay, 1. Max screens are Retina, and my monitor is not a Retina. That was 2. Yeah. So what we need to do is make it so this is compatible both ways, depending on what you're using. In Renderer, let's see. So in Renderer, when we calculate this position, we need to do different calculations based on wherever you're at. We can go like this. So all you need to do, if you have just a monitor that doesn't have Retina, it just has pixels, or at least mine does, you might have to figure out your own thing. This is how it works on mine. You can just go negative right there, and plus float plus float of view.bounds, because we need to add the height, right? Like we need to go, yeah, so we need the height, like I said, make it go from this 0 to this 0, so we'll just add the view.bounds, the height, and then this should put it down here at the bottom, and you get this light that follows around. Actually, I'm going to set this to black because let's copy this. Copy. Glad I got to cover all this. This is cool stuff. Okay. Okay, so we're going to set it to black and see what it looks like. It'll be easier to see. And I'm also going to stop rotating it so we can also view it nicer and clearer. Oh, but it looks so cool. We're going to go to our basic scene and stop rotating for the time being. Oh, my name feels good. We don't even need a cube. We can just do a plane in this case. But see that? Look at that. Oh, that's so cool. And you see it kind of changes. It has like this solar flare looking effect. Oh, that's so legit. No, if you're on a Mac, you're probably wondering like, what's wrong with my thing, man? It's like totally off. Because like if I were to drag this into my Mac, because I have my Mac desktop over here, or my Mac laptop on this side, and I have my computer normal monitors that aren't Retina, they're just basic 1080p monitors. If I drag it over into there, it starts messing up. So I figured out that we have to do a different calculation for that one, and I actually just wrote that down in my. That's why I had it open. Darn it! It's in that text edit. Hold on. Where'd you open? Yeah. So I had to figure this out. And I commented it out. Looks like okay. So let me go to my. Where are we? Renderer. Yes. So if you are on a Mac, do this right here. You're lucky I like you guys. I mean, I didn't have to do it. All right, so this 540 is going to be height. So view.bounds.height as a float. This is just a formula I figured out. It could be totally wrong, and I don't know why it works. I just plugged and chugged. A lot of plugging and chugging. I'm going to put it on this screen and show you what it looks like when I use my non-Retina. I think that's what it's called, Retina. Right? Oh, it's not X. Mouse position.x. Mouse position.x. This is mouse position.y. Right there. Okay, now let's see what it looks like when I. Oh, you see, now it's all off. But let me see if I put it over here. It's exactly right. And I don't know if it's going to work on yours. You might need to figure something else out. But when I put it over here on my laptop, it works perfectly. But now when I put it over here, and there might be a way to fix this. I'm not sure how. So, yeah, do whatever. Like I'm going to actually comment this. So we're going to say this is the non-Retina. I think it's because there's more pixels on the Retina. Or it does some other pixel stuff. And then this will say Mac. And I'll just put monitor. Mac. Yeah, whatever. And I'm going to just clean this up. Got to get going. I'm going to miss most of his gig. All right, so there's that. There's that. I'm going to comment out this stuff because I need it on my monitor for you guys. Oh yeah, look at that. And then we're gonna just add that rotation back because we've seen it. We know what's up. All right, uncomment that. I'm gonna add some extra rotation on the Y, just because. Oh man, this is so freaking cool. And then I'm gonna reduce. I'm gonna go to 50 on my renderer, and we can pass in whatever intensity we want. We could even put that as a slider. Not going to, but we could do whatever you want. Oh boy, and look at like the farther I am away from it, how dark it is. You see that? And then we get closer at it. Whoa! Oh yeah. So that's what we've got. Looks like it's like in the dark. Where is it? I'm looking for it. This is like fake lighting. This isn't lighting. It's kind of lighting because it is lighting the pixels, but it's. We'll get into different. Like so, if the light was up here, it would light that. Anyway. We'll get into all this stuff in the future. Thank you for watching. Should I cover anything else? Should I talk about anything else? What's my time? Oh man, it's 1:45. Longest episode yet. Cram packed with stuff. Yeah. So I'll see you when I see you.